Okay, so in this video, I'm going to go through section A1, which is titled confidence intervals. So in the general interpretation of a confidence interval is using this sentence frame. So the number here is whatever is given in the problem. So I wrote 90, 95, 99, because that's usually what they'll use. And so again, that value will change depending on what is given in the question. So the only correct interpretation of a confidence interval is stating that we are whatever percent confident. So it needs to have that word confident, that the interval from, and these two numbers are that maximum and minimum value using the confidence interval formula that I have written down here, which is the point estimate plus or minus the margin of error. And that calculates the true proportion of whatever we're talking about. So again, that's going to come from the context of the problem. So when you're looking at questions where it's asking about a correct interpretation, you're looking for that number percent confidence. So it has to say that. It's going to have options where it has that number percent and it talks about like that percent of samples are true or people or whatever, but it has to be a 95% confident. That's what we're talking about, not how much of something appears correct. So the calculation for this confidence interval is as follows. So we take the point estimate and we add or subtract the margin of error. So think about it kind of like the mean and one standard deviation. So it works that same way. So if I have an estimate of my sample proportion or my sample mean, that's my point estimate. And then my confidence interval is going to be that number plus or minus the margin of error. So that's going to capture an interval where I am 95, 90, 99% confident that the true population proportion or population mean lies within those two values. So that means that it's not 100% correct that that mean isn't there, but it's a pretty high confidence that I've encapsulated that value. So we're going to look at an example to show this concept. So we have a credit card company that's interested in the proportion of its customers who pay their minimum balance on time. So that's what we're looking for. That's that end part of the sentence. So we're trying to estimate the percentage or proportion of customers that pay their minimum balance on time. The company randomly sampled 500 records from the previous month. The 95% confidence interval for the true proportion of customers who pay in time was this interval. So from 0.705 to 0.795. So that means that we're looking at from 70.5% to 79.5% of their customers are paying their minimum balance on time. So the 95% is our confidence interval, and then these two values are the values between which I'm confident the true proportion lies. So if I'm thinking about this, these values are here. So 0.705 and 0.795. So that's the beginning and the end of my confidence interval. The point estimate, again, it might ask you for the sample mean if it's talking about mean versus proportion. That's going to be the average. So this is the average of the ends of my intervals because it's perfectly in the center, right? I added the same thing. I added the margin of error and I subtracted the margin of error. So that means that to do that, I'm going to take the two numbers that I was given in the problem, so 0.705, and I'm going to sum them, 0.795, to find the average of these two numbers. Since there's two of them, I'm going to divide that by 2. So if I add and divide by 2, that gives me a point estimate of 0.75. So my estimation is that 75% of their customers pay on time, right? Okay, so that's the point estimate. To find the margin of error, I have to work backwards. So remember, I'm thinking about margin of error as this number that I'm adding to get that end value, or the number that I'm subtracting to get that end value. So there's really two different formulas that I can use to find that margin of error. And so if I subtract the first two numbers, so if I do 0.795 minus 0.75, or if I subtract 0.75 minus 0.705, that'll give me that margin of error. I always want to subtract the smaller number from the larger number. Remember, margin of error is a distance, so it should be positive. So if you subtract backwards and you get a negative number, that's okay. You can just make that positive. So just remember that margin of error is always positive. So one way to find our margin of error is that we're going to take 0.795, which is my maximum value in my interval, and subtract that middle number. Or I can start with that middle number and subtract the minimum number. So I could also do 0.75 minus my 0.795, and sorry, 0.705. And either one of those equations gives us a margin of error of 0.045. Another way that I could find this value, so a third method to find our margin of error, is I can find the length of my interval. So I know it goes from 0.705 to 0.795. So if I do 0.795 and I subtract 0.705 and I divide that number by 2, right? So this 0.795, this is going to give me 0.90, which represents the entire length, right? So notice that if I'm thinking about the entire length of that interval, that's 2 margins of error. And so if I divide that by 2, that's going to give me 1 margin of error. So that's going to give me that same number, 0.045. Let's add a 0 here, sorry. So it's 0.090 and then 0.045 when I divide that by 2. Okay, so this interpretation, again, this is that sentence structure that I gave you at the very beginning. So we were talking about a 95% confidence interval in this problem. So that means that we are 95% confident. And again, if you're looking for an interpretation, you're really looking for that together, not 95% of the, right? It's not a 95% chance. It's we're 95% confident that the interval from, and then those are the two values that we were given the beginning and the end of our interval. So 0.705 to 0.795 captures the true proportion of what this question was talking about, which was customers who pay their minimum balance on time. Right, yeah. So it's that portion of, and I'm just gonna customers pay minimum on time. Okay, so that's kind of the general idea of what a confidence interval is. Again, you might have ones where they give you the point estimate and the margin of error, and you have to add or subtract to get those confidence interval values. But that's kind of straightforward, straight up using the equation. This is a little bit harder. So then you'll have some interpretation. So is it reasonable to expect that more than half of the customers pay on time? So we talked about this is 70.5% to 79.5%. So both of those values are more than half, right? If I think about this as a continuum, and I've got 50% here, my interval goes from 70.5 to 79.5. So my entire interval is more than half. So this one would be a yes. Okay, if I'm thinking about the next one, so this says, is it reasonable to expect that more than 75% of customers, so 75% would be here. Notice that this portion of my confidence interval is not more than 75, right? So I should do that backwards, sorry, let me fix. So more than 75% is this section, right? This is more than 75%. It does not encapsulate my entire confidence interval. So this would be no. So it could have been like more than 70.6, right? That would be a true statement because it's the bottom of my confidence interval. If it was less than 79, right? 79 is within my confidence interval. That would be no, because it doesn't encapsulate my entire confidence interval. Okay, so the whole interval needs to be within that range of values. So more than half, right? My whole interval is in that yellow highlighted area, more than half. However, only part of my interval is in that blue highlighted area that represents more than 75%. So then the last one is talking about an election, and it's really just another example of what we were just talking about. So a newspaper poll found that 54% of respondents in a random sample of voters city plan to vote for candidate Robert. So this sample would imply that he would win, right? So 54% is a majority. A 95% confidence interval for the population proportion is 0.54 plus or minus 0.06. So if I think about that, that means that I've got 0.54 minus 0.06 as my lower bound, so 0.48. So 48% is that lower limit based on this margin of error of 0.06. And then my upper bound is the sum of those numbers. So 0.54, I apologize for my writing, I'm on a different computer than I'm used to. 0.06, so that's 0.6. Okay. So if he's winning, right, then I would be essentially above 50%, right? And so if I'm thinking about him winning, that would be him winning. So win. So this is all talking about him winning. So if he were to win, I would have to have a confidence interval that encapsulated everything that's 50% higher than 50%, right? And so here we're between 0.48 and 0.6, so 48% and 60%. So sure, it's only 2% of our confidence interval that states that he would lose, but there's still a chance. So what that means is that we cannot predict that he can win. Okay, so looking at these options, I talked about you're looking for 95% confidence. So this first option where it says 95% chance, you should automatically eliminate that because it doesn't say anything about confidence. So notice that A and C are saying something similar. It's talking about him winning, but one's talking about a confidence interval and one is saying chance, right? So C would be a potential answer if all of the interval was greater than 50%, was greater than 0.5. Since it's not, we can't call and say that he would win, right? There is still an opportunity for him to not win. So B is the correct answer here because of the opportunity for it to not be greater than 50%. So again, when you're looking at these, it's 95% confidence. So if an answer choice does not say 95% confidence or whatever percent is in this problem, 90% confidence, 99% confidence, then it is not a correct answer. Okay, so you would want to eliminate that. If it's saying that it's telling you that it's wrong, it won't state that confidence interval. Okay, so it won't say with 95% confidence if we're saying that we can't make a conclusion because it's not in the interval. Okay, so that's all for 8.1. Remember, there is a little bit of calculations in the second part of this. There won't be as much calculations, but your only formula really is that the confidence interval is equal to point estimate plus or minus the margin of error.